This video is going to be largely conceptual, but I think it's really important to think about why you're able to do some things in math that you just assume you can do. So, for example, why can you combine like terms like 3 times x plus 5 times x? Why does that equal 8 times x? Because, you know, the thing that guides us all the time in math is the order of operations, right? So this 3 is multiplying with the x, right? And multiplication for sure comes before addition, right? So really you should be multiplying before you add, but yet we've been taught that you can just add these two things together and get 8x. And so here's the reason why. Before I say the reason why don't you pause the video, think about it for a couple minutes, and see if you can come up with why. And when you're ready, just unpause it. So here we go. 3, 2, 1, and I'll tell you why. The reason why is, well, see, this is multiplication, but multiplication is repeated addition. We are repeatedly adding x 3 times. 3 times x is x plus x plus x. That's what 3 times x equals. And 5 times x is, well, this plus right there. 5 times x is 5 x's being added. That's 1, 2, 3, 4, 5. So altogether, that is 3 of them and 5 more, which is 8. So the reason that you're able to add things that are like terms is because multiplication's repeated addition, and this is repeated addition of the same thing as this. This is repeated addition of the same exact thing this is being, this is repeated addition of the same exact thing. So you can just do it all together at once like that. That's why you're able to combine like terms like this. Okay, multiplying square roots. Let's talk about that. Why can you multiply the square root of 5 and the square root of 7 to get the square root of 35? Again, pause the video, think about it for a little bit, and when you're ready, just unpause the video. I'm going to say the answer in 3, 2, 1 seconds. Alright, here's the thing. Exponents are repeated multiplication. Alright, exponents are repeated multiplication. So sometimes these two things are exchangeable if the bases are the same, if you're repeatedly multiplying the same thing. Maybe what you don't know is that the square root of 5 is, square roots are exponents. The square root of 5 is 5 to the 1/2 power. The square root of 7, 7 to the 1/2 power. These are repeated multiplication. The same number of times. This is, you know, square root is 1/2 and this is 1/2, so that's why you're able to add those things together. It would be like this. Maybe this would make a little bit better sense. What if we had 5 cubed times 7 cubed? Would that equal 35 cubed? So what we're saying is these have the same exponents. Would this be the same? Well, let's talk about this. Would that be the same as this? Yes, it would. Exponents are repeated multiplication. These are being multiplied by themselves exactly the same number of times, so you can exchange those orders. So you can multiply these together because exponents are repeated multiplication, and these are being multiplied by themselves the same number of times. All right. Last one. Is the square root of 16 plus the square root of 9 equal to 5, or is it equal to 7, and why? Think about it for a moment. And the reason why is really the whole purpose of this video. Pause it, come up with your answer, and when you're done, unpause it. I'm going to go over it in 3, 2, 1 seconds. All right, here we go. So the order of operations says, again, that you've got to do exponents before you do addition. Square roots are exponents, like we said in the previous example. So the exponent, taking care of the exponent, which is square root of 16 is 4, square root of 9 is 3, that's 7. If you added 16 and 9 together, the square roots, you get 25, which is 5. This is wrong. This is wrong because you would have done addition before you had done exponents. So that's why this is correct and this one would be incorrect. Anyway, if you found this video at all useful, please click like and subscribe for more videos. Have a good day.